Hello, everybody. This is my sample presentation for our chapter challenge number 1. You can see that I've titled my presentation "Oh So Amazing" at example presentation. Yours will be much better than mine. So let me go ahead and show you what I've got here and what I'm expecting from you, and we'll let it unfold as it goes. So I am a solo group member, which means that my work was completely on my own. So I created my supporting materials, I created my video, and I created this presentation. The scenario I was working on was Melba's second request, and she said that the car starts at rest somewhere on the left-hand side of the screen. It accelerates to 30 centimeters per second in 0.5 seconds, and then it continues to the right at 30 centimeters per second. So the first thing I did is I broke that down and said, okay, here's what it was in 0 to 30, right? And I put that into stop motion animation speak, saying that it starts at 0 centimeters per frame and then accelerates up to 1 centimeter per frame. And it takes 15 frames for that change in velocity to happen. The acceleration needed to be calculated next, and I used the definition of acceleration here, where I said my change in velocity goes from 0 to 1, and it's over 15 frames, which gives me a final acceleration as it is speeding up of 0.07 centimeters per frame squared. I then needed to figure out kind of what my change in x was so that I can put my actual car down and figure out where it's going. I used this equation here of my change in x is equal to 1/2 at squared plus my initial velocity times time. I plugged in the things that I knew, and I left my t kind of as it was because I used this for every single frame. So when I filled that in every frame, this is what I've got. I started out putting the car at 10 centimeters and I left it at 10 centimeters for 10 frames. So nothing happened for 10 frames. My velocity was 0, my acceleration was 0. But after those 10 frames, I started to accelerate at 0.07, which meant that my velocity increased by 0.07 every time, and my position increased as followed by the 1/2 at squared as it started to go. I then eventually made it up to a total position of 22.8, and my velocity stayed at 1 once it got there, 1 centimeter per frame. And my acceleration, once I was no longer speeding up, my acceleration dropped to 0. I put together some graphs of this data. This is the position graph. That position graph starts out here at 10 centimeters, and it stayed 10 centimeters for a while. It then accelerated for a bit, 15 frames, and then it traveled off at a nice even pace afterwards. So that's how my position changed. My velocity was 0 for the beginning because it was not changing, and then it traveled at an increasing velocity with a constant acceleration, and then my velocity stayed at 1 for the last few frames. My acceleration is 0 to start with because we're not doing anything, but then it goes to a constant acceleration of 0.07, and the last few frames, it is no longer speeding up or slowing down, and so it is at 0 for the last few. Here's my final video. It's short, so let's take a quick look. I'll play it a couple times, but off it goes to the right. There it is. It's hard to see in the screen capture, but we'll do the best we can. The highlights for this for me were actually finishing the project, getting everything together, and having a totally satisfying kind of project that I felt good about. The hard parts were trying to figure out how to make the film work and all those little pieces of the supporting materials. There's a lot of math going into it, so trying to make sure all those pieces were balanced was a challenge. So I look forward to seeing your videos too. Please make sure that they get uploaded to Flipgrid, and we'll see you in the next one. All right, take care, everyone. Bye-bye.